In this video, we're going to talk about how we can start spawning the obstacles in our game. So here's a quick little preview of what we're going to be brewing up. You'll see that we have obstacles that spawn from all four walls. And if we shrink the walls, the obstacles know where the new walls lie. So they keep spawning within the walls parameters here. We haven't figured in collision yet. That'll come in a later video. But they even adjust as the walls are shrinking. And there you can do waves. You can have complete control over how many obstacles spawn. So without further talking about it, why don't we go ahead and jump into the code here. So I have a brand new little scene here. And why don't we go over what we're going to do, what we need our spawning obstacle controller to do. Well, first in this video, we have to make a moving obstacle. We're going to create a prefab that will serve as our temporary obstacle for prototyping purposes, and we're going to attach a mover script to it. And then we're going to randomly pick a side that we have to spawn our objects from, and then we have to randomly pick a position on that wall from our objects to spawn from. So we're going to randomly pick a wall to spawn from, and then we're going to pick a position alongside of one of the walls that we're going to spawn our object from. And then we're going to control how fast the obstacles are spawned one after another. And then we're going to control how many obstacles are spawned in a single wave. And then we're going to make an obstacle prefab that moves in a single direction. I think that's number one. I think I have that down twice. Yeah. And then we have to make sure that obstacle changes its move direction based on what side it spawns from. So if it spawns from the right wall, we have to make sure it spawns or moves to the left direction. If it spawns from the bottom wall, we have to make sure that obstacle moves to the top direction, bottom to top direction. And then we can set up something where the obstacle will change its speed based on different rules in the game. So if you pick a power up that slows down the speed of the obstacles or get a penalty where they speed up, we'll be able to have a variable that we can control in that regard. All right, so I'm going to pull this over to the side, and why don't we get started by making a moving obstacle. All right, so to do that, we have to first make an obstacle prefab. And I'm going to turn off my player prefab right quick by unchecking its game object in the inspector. And I'm going to do this somewhat fast. I'm going to make a capsule collider, or rather just a regular capsule mesh. I'm going to change its rotation to -90. And I'm going to give it some fins so we know which direction that the obstacle will be facing when it's traveling. So I'll just do something like this real quick. Rotate this and rotate it in the Z direction, 45. -45 for this one. So I've created a missile type looking thing. And then I'm going to, when I got all of my meshes kind of put together, I'm going to create an empty game object. I'm going to call this obstacle underscore mesh. And I'm going to parent all of them under obstacle mesh. Actually, before I do that, let me undo that. Let me make sure that my obstacle mesh empty game object, its values are reset. And then I'll parent them all there. And I'll create another empty game object, and this one will just be called obstacle. So we have a game object for all of our meshes to be grouped under. Yeah, so we have actually I did that wrong. All right. So there's our obstacle mesh. It's got all of our meshes. Then I'll parent that under obstacle as our main game object for our obstacle here. And I'm going to go ahead and make a new material real quick. We'll call this obstacle mat, and we'll make it red so we can easily tell the obstacles apart. And I'll expand my obstacle tree here, and I'll just apply that material on all three of my meshes there. All right, so there's my obstacle. I need to unparent my obstacle mesh, reset. Make sure all my transforms are reset while I'm making this prefab. There we go. So there's my obstacle prefab right there. All right, so why don't I go ahead and drag my obstacle into my prefab folder, and now we have a prefab for my obstacle. Next, I need to make a mover script. We're going to just call this mover. It'll be a generic script. Hopefully we'll be able to apply it to power-ups or anything in the game that will just move in our game view. And I'm going to parent it to my obstacle prefab there. And you'll notice that if I select my prefab, I don't have that script attached to it yet. I can go to prefab, select my obstacle that I've attached my script to in my hierarchy, and go to prefab and apply that prefab. So now that my obstacle in my prefabs folder will have the mover script as well. So we're just updating our obstacle game object. We're updating it so it also applies to my obstacle in the dugout in my prefabs folder here. All right, that's going to be important because we're going to instantiate this prefab here. We're just working on our obstacle right here in our game view. Next, I need to go into my mover script, and I need to make some variables real quickly. Let's get started with variables. I'm just going to delete all this stuff, and we'll make whatever functions we need as we go. So a few variables we'll need, and I want to make them all public to start out with so we can see them in action in our inspector. First, I'm going to make a move speed variable that will control how fast our obstacles will move. Public float lifetime. So we're going to have, temporarily, we're going to have a script that will destroy our objects after a certain amount of time. In the future, we won't need this variable because our objects will be destroyed by colliding into objects, but it will serve its purpose during this prototyping period right now. Then I'm going to make a public string, and this string is going to dictate what direction our obstacles will move in. And we're going to use a string so we can clearly see that, yes, move direction will be right or down or bottom or top, whatever you want to call it. String will be the best way to use that variable right there. Then I'm going to make a public vector 3, and we're going to call this our direction. This will actually control the vector direction that we'll be moving in. And you know what? I'm going to come at the very top here and make another public game object variable or a public game object variable and call this object mesh. This is going to be useful for rotating just the model of our object so it is more in line to the direction that it is traveling. All right, so I'm going to hit Control S and save that. And let's see my obstacle mover script now. All right, so now that I have my variables described here, I'm going to go ahead and assign some values to them. So I'm going to make my move speed about 5. I'm going to make my lifetime be destroyed after 5 seconds. And for my object mesh, this is why we made a special game object just for all of our meshes, because this object mesh variable right here is going to control the direction our obstacle is going to point in. Okay, so that looks all well and good. So my obstacle is coming along now. So let's go back into my mover script and let's give it some logic to make sure we're getting the right kind of movement out of our obstacle here. So I'm going to call a void awake function now. So as soon as the object's instantiated, it'll become awake, for instance, and all of this code will be executed as soon as it's instantiated. So what do we need to do is first, let's go ahead and handle our destroy over our lifetime. So we're going to destroy this game object that the script's attached to after our lifetime. All right, so we've got our destroy taken care of. I'm going to hit Control S to compile and save. So now we need to determine what to do for each direction that we're going to be traveling, because our obstacles and whatever is going to be moving in our game, they're going to be 4 different possible directions that it can travel. So we need to have 4 different conditions to handle those 4 different directions. So I'm going to go ahead and create the code for moving right. So we're going to say if movedir equals, and it's a string, so we'll type in right. So there we go. So now why don't I copy this code right here. That way I can quickly bang the rest of them out. And we're going to do an else if here. And why don't we say if it's left. And I'm going to copy this block because I need another else if. And then we're going to handle our top direction. And then we're going to handle our bottom direction. Or actually, you know what? Maybe I should do up. Whatever you do, whatever naming convention you use, you got to make sure that it's set in stone, because these string variables are going to be very important when we start making our spawn controller. I think I'm going to change it to up direction, just so it makes more sense, because we're going to be moving up, we're going to be moving down, we're not going to be moving top, and it doesn't make sense to say we're moving bottom direction. All right, so I'm going to hit Control S to save and compile. And now I have my 4 conditional statements that'll handle the movement for each one of my directions here. All right, so now we need to actually add the code that gets our obstacles moving. So we're going to say direction, and this is our vector3 variable we described here. It's going to control what direction we're going to be moving in. Direction equals, and then this is the big one, vector3 dot right. And that's all we have to do for setting our direction. Okay, this will dictate we're going to move to the right, but it's not actually moving our obstacle yet. We'll do that in our void update function in a second. And then we got to change the rotation of my object. So I'll go object mesh, like so, and we're going to set its dot transform dot local rotation. We're going to set it to, and then we're going to use quaternion so we can really nail down our values in our transform rotation up here. We're going to do quaternion Euler, and then it's going to ask us for 3 different floats that correspond to the X, Y, and Z rotations. So we're not going to move it in the X at all. And now we have to figure out what values to put in our Y and Z. So I'm going to go ahead and Control S and save this. And the best way to do that is to go ahead and select my object mesh here. And I think, yes, since we have an empty game object called obstacle mesh, we don't have to worry about the single rotations in the Z-axis at all, or the X-axis, depending on whatever. We just have to worry about rotating this guy right here. So we only have to worry about our Y value right here. So that'll be much easier. That'll be much easier to control. Let me unexpand that. So I'll set that back to 0. So if we're moving to the right, then our little missile will need to be facing right. So to move to as we're moving to the right, we need to rotate our obstacle mesh group 90 degrees in the Y direction. So let's go back to my code. So 0 for the X angle, 90 for the Y, and 0 for the Z rotation angle. And that about does it for handling the right direction here. So now I'm going to copy this code, go ahead and paste it in all of these if statements here. I mean, I could make a function that handles all this, but at most I'd just be saving 4 lines of code. So I'm not going to bother trying to, save some line space here. We'll keep it simple. So for left, I'm going to move vector3 left. And it looks like I need to, and I'm going to double check with my object mesh here. It looks like I need to put it in the -90 Y rotation. So if I'm moving up, it looks like moving up, all of my rotation values will be 0. So that'll be fine. And I'm guessing when I move down, I need to do 180 degrees right there. And just to prove it, I'll go ahead and rotate my mesh, and it's close to 180. There we go. All right, so this reset all of my rotations on my obstacle mesh. So now we have code that as soon as our obstacle is instantiated, as soon as it becomes into play on the field, we can set what direction it will be traveling in, and we'll set its rotation so it's looking in the right direction. This will all be dictated by what our move direction variable will equal. So pretty self-explanatory by now. And then from here, I need to go outside of my void update function. I need to make a new function, or my void await function. And now I need to make my void update. And it's just going to be a simple line of code. We're going to say transform dot translate, and then we're going to say we're going to translate by the direction times our move speed times time delta time dot delta time. And that pretty much does it for our mover. So why don't we test it out real quick? So here's my obstacle, and I need to give a direction here. So I want to say, let's move down. So I'm going to type down in my move direction and hit play. And we seem to have forgotten to update our vectors right here. So if we move up, what are we going to be moving forward in the Z? Yep, looks like we'll be moving forward if we go up. So I need to go back in and update my vector 3 to forward. It's important to keep testing out your game so you don't get bugs like that. And 30 minutes down the line, you're wondering, why aren't my obstacles going in the right direction? So there we go. We can see that as I move down, my missile rotates downwards and now proceeds down. And then after a certain amount of time, it destroys itself. All right, why don't we test it going up? There we go. And just do one more test. We'll test it going right. All right, great. Now my obstacle has a mover script and everything is good. So I'm going to go ahead and apply all these changes to my prefab just to make sure that my prefabs are set. There we go. Actually, you know what? I'm going to delete my move direction, have nothing there, because that'll be updated by my spawn controller. And I'll go ahead and, leave my obstacle mesh value assigned to it and just give it some temporary or some default values right there. All right. So now I will delete my obstacle from my game scene. And why don't we check my prefab obstacle to make sure, there we go. We have our mover script still attached because remember we did that apply update. And then my obstacle mesh is attached and I still have my default values set up. So prefabs are really neat, really powerful. All right. So now we're going to create our actual spawn controller. All right, so I'm going to go ahead and just kind of lay the groundwork for it, and then I'll break down the logic that we'll use as we get closer to some of the heavy lifting code we're going to have to write for it. So what I'm going to do is I'm going to go into my scripts folder. I'm going to create a new C# script, and we're going to call this spawn controller. I'm going to make a separate script for spawning things. I don't want to just for readability sake, I'm not going to put all the code into my game manager. I want to have just a separate script just for my spawning. And I'll go ahead and tidy this up. Start with a blank slate. But I am going to attach my spawn controller to my game manager object. So now I have my game manager script attached and this new spawn controller script attached to it. All right, so I'm going to open up my spawn controller. And we're going to start out by making variables. And I'm going to create all the variables we're going to need to get this moving or to get my spawn controller working. And I'll explain what each one will do as I make them. So first, we're going to make a public game object variable called spawned object. This is going to be where we assign what we want to spawn. All right. Well, we want to spawn maybe the power up or maybe a hazard. Then, okay, good. All right, so the next one we'll do is public string obstacle direction. And this will be what we use to update our move direction over here in our actual mover. So we'll pass our obstacle direction string into our mover script, and that's how we'll be able to tell the obstacles or the hazards what direction they'll be moving in. And I'm going to create a public float next called obstacle speed. That'll dictate our speed of our obstacle, and so it'll update our move speed in our mover. Same way we'll be updating our move direction in our mover. So this spawn controller is going to control a few things that our mover script will need to know. And then when we create a public int spawn count, this will be how many different obstacles are spawned in each wave. So if you want to be more specific, you say spawn count per wave. It's a little bit long, but it's a little bit more descriptive. And then I'm going to make another public float. And I'm ordering them in this way so it's more logical when I look at these values in my inspector. So that's why I have these floats separated. It's about how they're displayed. Then in this float, we're going to say spawn wait. So this will be the time between obstacles spawned in a wave. So we have wave 1. The spawn wait will dictate how frequently the obstacles spawn in that particular wave. And then we'll have a wave wait time that will say, okay, wave 1 will spawn, and then we'll wait, and then we'll spawn wave 2. Now we're going to make some private variables that will only be useful in our spawn controller script. So we'll say private, and then make some floats. And this is going to be our minimum position that our obstacle will spawn alongside the wall. Max position that it will spawn alongside of one of our boundary walls. And how far out it'll spawn according to our walls. So I'm going to talk about what I'm talking about here. So our minimum position and maximum position and side position. All right, we can actually see these new variables populate on our spawn controller. So minimum position, let's say we're looking at our top wall here. Our minimum position will dictate, okay, what range are these obstacles or hazards going to spawn alongside this wall. So our minimum position will say, all right, at a minimum, we'll spawn on this side of the wall. At a maximum position, we'll spawn all the way over here. So these two positions will dictate, these obstacles will be able to spawn in between them using a random range function we'll get into in a second. Side position says, okay, this is our 0 point in our grid. Side position will say, okay, the wall is this far out. So it'll be like saying the wall is here, like so. That'll be useful for getting the obstacles to spawn directly inside of our walls, so it almost looks like the walls are spawning our obstacles. All right, I'm going to make sure that's exactly at 10 again. All right, so that's what those private floats will handle. We'll make some new private floats. Private float random position and our random side. These will hold the values for this will hold the values for our random range for our instantiating our obstacles, and we'll use those in a little bit. And then we're going to create a private vector 3 called spawn position, and that'll dictate exactly where our spawn position will be after we figure out the min position, the max position. Use those to get our random position, and then finally we'll apply that to our final spawn position per each obstacle. All right, so we got all of our variables made. I'm going to hit Control S and compile this. Look at my game manager. And we haven't seen any new variables populate because they are private. We won't see those in our inspector. Public variables we will though. But private ones, we're only going to use those inside of our spawn script. So what we need to do is we need to find a way to easily add pauses to all of our spawns, because we're going to need a pause between when the obstacles are actually being instantiated in a wave, and we need to add pauses between our waves. And these two variables right here will give us a lot of control over the flow of our game. So we're going to use coroutines to handle that, Coroutines are really handy special functions that allow us to add pauses really easily. So to make a coroutine, why don't we call void start, and we're going to say we're going to call our coroutine. We haven't made it yet, but I'm going to go ahead and call it because it's a simple line of code. And we're going to call our coroutine spawn objects. All right. And then since it's a function, we have to add those parentheses there, and then we'll close off that call. And our spawn objects coroutine function is red right now because we actually haven't made it. So why don't we go ahead and make it real quick? So outside of my void start, and this is going to be a little different, it's going to be called, we're going to use IE numerator spawn object. So there we go, declaring the name of our coroutine. Hit Control S. And it looks like we have a little bit of misspelling, objects, like so. There we go, no more red. Hit Control S. And then we're getting a error sign here because we haven't added a return value to our coroutine yet. But we'll get into that in a second as we build out our spawning logic inside of our spawn objects coroutine. So what is this spawn coroutine going to actually do? So I'll bring up my handy dandy outliner here and we'll go over what this coroutine is going to do. First, it's indefinitely going to spawn waves of obstacles. So we're never going to stop spawning waves. We'll be able to use our spawn count per wave. If we set that to 0, then that'll effectively turn off spawning. But behind the scenes, we're still going to be spawning waves, but waves of 0 objects. So that'll be a safe way to make sure that our coroutine will work constantly and give us control over whether or not we want to stop the spawning if our game design calls for it. The second thing our coroutine is going to do is spawn a number of obstacles per wave. Okay, and each one of these little bullet points here actually correspond to logic that we'll get into down here. I'm just going to kind of outline what we're going to be doing here. So after we create a for loop to spawn the number of obstacles per wave that we need, inside of that for loop, we're going to find the minimum and maximum positions an object can spawn along the boundary wall. So remember, we're going to find that position alongside of each of our walls here. And there's something to note here. Since we're using a square playing field, that makes all of these positional values relative. So all we have to do is find a general position, and it'll apply to all these walls. And then when we're making our new vector direction, our new director position for our obstacles, then we'll take in consideration which actual wall our positions are relating to. So that's a nice little trick we're using with our square playing field here. And then we need to find out how far away the object will spawn according to how far out our wall is, because we want our objects to spawn from within the wall. So we have to match how far out or how close in our walls are. And since our playing field will be shrinking, our coroutine will do a nice job of figuring out the exact dimensions of our current playing field at any given frame. And then we're going to find randomly what wall we want to spawn each of our objects from. And then we'll randomly find the position along that wall to spawn our objects out of. So this is when we're using our random range functions there. And then we're going to have 4 different conditions that pertain to each one of our walls here. So this is where we're going to kind of start breaking down into what wall each wall specifically does. So 4 conditions and will be needed there, 4 if statements. And inside of each of these conditional if statements, we're going to do the following. We're going to set the obstacle's move direction. So basically, what direction our obstacles are going to move from. Are they going to move from right to left because we're on the right wall, we're spawning on the right wall? Are they going to move from top to bottom since we're we've randomly selected the top wall to spawn from. So we need to set the direction that they're going to be spawning from. And then we need to set the obstacle spawn position according to the wall that it will spawn from again. So we'll actually go in and say exactly right here on the top wall will our obstacle spawn from, or exactly right here in our right wall will this obstacle spawn from. Then after we get the direction we're going to be moving our obstacles, exactly where the exact point in which our obstacles are going to spawn along the wall, we're actually going to instantiate the obstacle at that spawn position we've found out right there. And then after we instantiate it, we're going to wait a period of time before the next obstacle spawns in our wave. So after we go through our for loop, we've spawned all 5 obstacles in our wave. We've gotten out of our for loop. Then we're going to wait a period of time before the next wave starts. All right. So all of these things we're going to accomplish as we get into coding the coroutine logic. So let's just jump right into coding this logic here. And we're just going to go straight down the logic that we've created right here. Sometimes it really helps to make an outline of exactly the types of things we need to do, so that when we're coding it, we kind of have, a little timeline that we need to follow of, okay, we need to do this, and we need to do that. We need to accomplish all these things within our logic. So why don't we get back into our game project right here. And we're going to get hardcore into the code now. So I'm going to bring up MonoDevelop. I guess I'll position it right there. Maybe make it a little bit wider. Sorry, MonoDevelop decided to crash on me real quick, so I brought it back for us. All right, so the first thing we're going to do is we're going to create a way to infinitely spawn obstacles. All right, so our game starts. We're going to call our coroutine at the very beginning of the game, and that's going to start this while loop, and it's going to be true. But wait, that's like an infinite loop. What's going on here? It works with coroutines. It's going to constantly go through all of its code, and since we're returning a value that will satisfy this error right here, while loops just seem to work for constantly being true here. It's always nice when rules are broken. It really helps your brain out. All right, so while I have while equaling true, then I'm going to spawn constant waves of obstacles. Now I need to create a for loop that'll control what each wave does. So we're going to say for, and we're just nesting that within our while loop. We're going to say for I, that's our counter variable, we'll set that equal to 0. And we'll say as long as I is less than the spawn count per wave. So if there's 5 obstacles we want to spawn in our wave, we'll loop through our for loop 5 times using this for loop logic, and then we'll increment our counter every time we loop through. All right, so our while loop will constantly spawn waves, and our for loop will spawn all of our obstacles within a single wave. Okay, so the next thing we're going to do is we're going to find the minimum and maximum values an object can spawn from. All right, and we've set ourselves up to make this relatively easy. I'm going to go ahead and open up my game manager script right here. And remember when we made these public static floats, boundary position and boundary scale? Well, since these are global variables, we'll be able to see exactly how big our boundaries are and exactly how far out they are. So that'll really help with nailing down our minimum position and maximum position. So I'm going to go ahead and come in here and code that. So I'm going to figure out my minimum position, and we're going to set this equal to our GM dot boundary scale. All right, but we can't just leave it at that, because right now, let's see, I'm going to go ahead and change these minimum and maximum positions to public so we can see them update inside of our inspector. Okay. So if I hit play, then that will crash Unity because we haven't added a return value for our coroutine. So yes, our while loop right now is dangerous to our working environment. But like I said, our coroutine will have a return statement at the end of it that will create a while loop that equals true that will not crash our scene. So at this point, so you don't make any errors with crashing your scene, go ahead and save your scene, save your project, so in case you do encounter a infinite loop, you'll be able to bring it right back without losing any progress here. So I was just trying to show you that when we update our minimum position, that's not going to be the value we need. Because right now, boundary scale gives us 18.8 right now. And 18.8 or negative 18.8 is all the way out here. So it's not a very good minimum position because we'll be spawning asteroids out of here. What we need to find is the minimum position right here. This is kind of the minimum position we want to look at. Let's see. Actually, what are we trying to do first? I guess we'll use top as our example here. So here's our minimum position we want for our top wall. Notice how its position is negative 8.85. That's because since our top wall is right in the center of our playing field, its center point is 0. We have positive space and negative space. So really, our minimum position will be half of my wall right here in the negative field. So half of my wall from 0 to the end right here. And then we also need to add a little bit of a buffer here. So if we go all the way out to our wall here, yeah, our wall is at negative 10 right now. But that means if we make that our minimum position, obstacles are going to spawn within my wall here. So we need to add about a unit's worth of buffer. So a 1 unit measurement of buffer right there. So we got to do two things. We got to figure out half the size of my boundary wall because we're figuring it for half. Let's just say that I'll use the screen to cut it off. We only want to figure out half of our boundary for this negative position and half of the boundary for our positive position. And plus we need a buffer zone so we're not spawning within our walls. So we need to come in here and spice up our boundary scale code real quickly. All right, so how do we do that? Well, for our minimum position, we're going to say boundary scale. Get that semicolon out of here because we're not done making our equation. So our boundary scale divided by 2. So after we divide it by 2, then we're going to subtract 1 from it to create that buffer. And since it's minimum position, we need to get a negative value out of here. So we'll go ahead and make that equation negative. And actually, I'm going to use parentheses to clearly define what we're trying to do here. So in this inner parentheses, we're going to half my boundary scale by half. That'll give me just the measurement of half of my top wall right here from 0 to negative 10. And then we're going to subtract 1 from that value to give us that buffer so we're not spawning within our wall right here. This buffer will account for that. And then since my minimum positional value kind of exists in the negatives right here, I'm just going to make this whole equation negative. All right, so negative. And then I'm going to do the same thing basically for max position with a few changes. We're going to say maximum position is equal to gm.boundary scale. What's going on here? gm.boundary scale. I have a random. There we go. I got a little syntax. Boundary scale divided by 2 minus 1. I'll come in here and use parentheses to make sure we're getting the exact calculations we want. And we don't have to make this negative. So I don't have to add the little negative sign right there. All right. Good stuff. Let's see. Actually, I'm going to go ahead and so they kind of look the same. So that's just order of operations working for us. We're having the size of my boundary, and then we're subtracting 1 for the buffer, and then we're making it negative for a minimum position and positive for max position. That'll give us our minimum point over here and our maximum point over there. And since, again, our playing field is square, these values will be relative for each of our walls here. If that doesn't make sense, maybe when we start plugging in those values for each individual wall, you'll see how we can use the same kind of values for each of our walls there. All right, so now we have to find out exactly how far away we have to spawn our obstacles, depending on how out or in our wall currently is as it's shrinking. So that'll be an easy line of code. We can just say, we can use our boundary position to do that. So we'll say our side position. Remember our side position we declared right up here. Our side position will equal gm dot boundary position. And that's all we really have to do for that. Our boundary position was declared right here. And then whenever we go through and shrink our boundary, every time we shrink it, we update our boundary position and our boundary scale. We've already taken care of that when we were creating our shrinking playing field. All right, great. So our spawn controller is starting to come along. So we know the minimum position and the maximum position now, and we know how far out to spawn our objects. Now we need to start working at getting some random values. We need to get we need to randomly pick a wall to spawn from, and we need to find a random position along that wall to actually spawn our object from. So let's do that right now. So we're going to say we're going to use random.range to find some random values. So let's say our random side is going to equal random.range, and we're going to find numbers randomly from 1 to 5. All right, this will give us random numbers 1, 2, 3, and 4. All right, give us 1, 2, 3, 4 randomly. All right, so the 1 is basically where we'll start from, and that is included within our range. And 5 means all the numbers from 1 to 5. And it doesn't include 5. I was a little confused by that too, but I think it has to do with float calculations and decimal calculations, just the way that the random range function works, basically. But this will give us random numbers from 1 to 5. All right. Control S, save that. And I want to go back up here, public float. And I'm going to make these values public. And so I can skip ahead and test out my coroutine up here. I'm going to go ahead and add that return value that makes it safe to have this infinite loop. So we'll do real return new wait for seconds. And we're going to wait our wait wave time right there. I'll hit Control S. So this line of code basically will say, okay, I'm going to loop through my while loop, and after I'm done going through my while loop, doing all this stuff, I'm going to wait these amount of seconds, and then it will be okay to go back up and go back through my while loop. And the game understands that. It won't get bogged down in an infinite loop. But just to be safe, I'm going to save my scene and my project. All right, so if I go to my game manager, now we can see my random position and random side now. What we want to do is we want to pay attention to random side, and you'll see it cycling through. Let's see, spawn count, spawn wait. So every second it'll choose a new random side, 1, 2, 3, and 4. Oh, let me take it off of maximum play. So 3, 3. Let's see, it's not changing. Let's figure out what's going on here. It's because we haven't given a random yield or a yield return wait new for seconds right here. So let's go ahead. We have to add one in here. And this will be the pause between each instantiated obstacle inside of our current wave. So we'll do spawn wait, the actual wait time between spawns. There we go, like so. So now our coroutine has our pauses in it. 1, 2, 3, 3, 3, 3. It was just doing it. What gives here? Let's see. So here's a good example of how these values will change what we're doing here. So spawn count per wave, we're going to spawn 5 different obstacles. So we'll get a random side 5 times per wave. So let's say, let's do 5 different random side gets. And then we're going to change that every half second. And then wave wait, we're going to wait 2 seconds between each wave. So if we hit play, every half second, we're changing to a new value. When the next wave happens, then we get some new values there. And notice how they're just going in between 1, 1, 1, 1, like so. So we got some random going on as we were looping through our our weights right here. All right. So now that we got our random side picked, that'll make sense in a second whenever we create our conditional statements for each one of our random numbers we're getting here. So why don't we go ahead and figure out our random position. All right, the code will come together when we get there. It's kind of a chicken before the egg kind of thing going on right now. Kind of need to see what's going on, and then you just have to take it on faith that these yield rate wait return for seconds are doing what they're doing. All right, so I'll explain them more in depth when we get to that part. All right. So now we need to figure out our random position. So these values are still going to be relative and won't pertain to any one wall right now. We just need to find some generic random positions going on right now. So we'll do a random.range again, but the difference is we're going to use our min position and our max position now. All right, and we figured that out right up here. So I'll hit Control S. And why don't we see what's going on when we play the game now? Notice how our random position is just kind of popping off. We're getting random floats here, and that'll dictate where alongside the wall we're going from. And this will go between negative 10 and positive 10 right now, because guess what? Or actually, I guess negative 9 and 9, because our walls right now have a scale of 20. So negative 9 units right here for our minimum, in between positive 9 units right here. So that's what we're seeing right here in our random position generator. So we're getting our random sides and our random positions. So now we need to make sense of what to do with these float values here. We're going to put those to work in a second. But before we can even put those to work, we now have to have four separate if statements that pertain to each random wall. So let's put those random 1, 2, and 3, 4, 1, 2, 3, and 4 numbers right here. Let's put this little statement to use now. So we're going to say if random side equals 1, and we're going to say this is our right side spawn. And we're just arbitrarily saying that whenever we randomly get 1 as our random side, then we're going to do all the things that pertain to the right wall. We're just kind of arbitrarily picking that. There's no reason I could have done left wall there, but I'm keeping it right, left, up, down. Let's keep with that kind of logic. Then we're going to say else if random side equals 2, and this is our left side spawn. And then open and closed curlies. And then I'm just, to save typing time, I'm going to copy and paste these. And we'll just update it. So if it hits randoms, if it hits 3 there, that's what it will do for our top side, 4 bottom side spawn. All right, great. So now you can see that our random range right here is coming in handy, because If it hits 1, we're going to do all the code for our right side spawn. If it hits 2, we're going to do all the code that pertains to exactly the left side spawn. All right, so now we have to figure out what to put in these if statements, right? Okay. So, yeah, and I would actually put these comments in too, just to help you remember exactly what if statement is controlling which wall. All right, so we need to do about 4 different things for each one of these if statements here. And you know what? I'm going to go ahead and get rid of this little spawn weight right there, because that's going to go in to this right here. All right. Actually, I'll leave it in. We might be able to get away with only having to write it once. But I'll get into that after we create the logic for each one of my walls. All right. So if our random side equals 1, we're going to tell what direction our object is going to travel. So if we're going to the right side, our obstacle direction equals, and since it's a string, we're going to do right. Make sure you get exactly the right spelling, because guess what? This value right here is going to be passed into our mover, and it's going to pass this value. It's going to check and see if right and right are the same. So if we random side equals 1, then our obstacle direction equals right. And then we're going to write some code in our mover in a second that'll say, okay, our move direction is right. Now we're going to actually move and point in that direction. So our mover and our spawn controller are going to work very closely together in this regard. So it's very important to make sure we're pointing out what direction we really need to be going as it pertains to which wall we have randomly selected. And then we need to update the actual spawn position, because right now we just have some very relative, positions. It could be -8 and 8 right here, or it could be 8 right there, and then -8 right there, or just these random positions. We haven't exactly said what these random position. We haven't really said how that's going to pertain to each wall. That's what we're going to do right now. That's what we're going to do right now. We're going to use a spawn position. Now we're going to use our spawn position vector variable, and we're going to set that to a new vector 3. And then we have 3 values here, an x, a y, and a z to take into account. And these 3 need to be 3 separate floats. So where we put our values here is going to determine exactly where these objects are going to be spawning from. So we have a random position and a side position. These 2 values right here are going to really let us know exactly what wall, where we're going to spawn these things alongside the wall. So it's up to us to make sure we're putting them in the right x, y, and z coordinates. So that might be a little confusing. How are you supposed to know that? So that's why we'll go back into our game scene over here. And if we're figuring out my right wall right now, I'm going to grab my player character. And this is my right wall right here. And I'm going to push him over inside the wall. So let's pretend that my player is the actual obstacle right now. Just something where I can see the values in my inspector. All right. And then up and down, this will be our random position right here. So up and down is our random position. And then back and forth right into the middle will be our side position variable. All right. So as I move it back and forth, I can see that I'm updating the X position. And as I move my player up and down, I'm updating my Z position. Okay. And you know what? Am I looking at my right wall? Let me just select it. Okay, this is actually my right wall. My camera was turned around. So that could have been really tricky. Okay, because I was actually looking at my left wall thinking that those values were for my right wall. So with my right wall now correctly looked at, I knew that's my right wall now. So my position X will be positive, and my Z will be my random position. All right, so plug that into this new vector 3 right here. So X will be my side position. So the position of my sidewall, Y will be 0, and Z or Z will be my random position. There we go. So, hope that makes a little bit of sense. My new vector 3 is describing the actual specific spawn position that I'm going to actually spawn my hazard from, or my obstacle. Okay, so I need to describe in the X direction, or in the X position, how far out this will be. So my player, this is my obstacle right here for the time being. It's going to be in this X value right here. So we're going to put my side position there. Y is never going to be used. And Z, if we go up and down my Z position right here, that's 2.14. That's 4.47 in my Z, negative 6.7. So we'll just put our random position right there. All right. So why don't we go ahead and do this for all of my walls here. So if that's a left side spawn, I'm going to set my obstacle direction to left. And what do I need to do here? Okay. What do I need to change? How do I need to make this new vector 3 different than my right side wall vector 3? Well, why don't we go back into our game scene and find out. So my Z, I'm going to go ahead and move it. So the only thing that's changed is my X value, my X positional value is negative now. So all I have to do is say, well, side position will now be negative, and everything else stays the same. My random position will still be in the Z transform position there, but my side position is now in the negative world. All right, great. So why don't we go ahead and copy this code again. And at this point, I know I'm doing good, so we'll say up. Obstacle direction will be going up. Remember, their strings have to correspond to our mover. I'm going to go ahead and come down here and say bottom side. Actually, you know what? If top side, I think I've gotten this wrong. If we're spawning on the right side, doesn't my direction need to go from, this is the right side, doesn't my direction need to go left? And if I'm on the top, doesn't my direction need to go down? So I think I have messed up. I think I need to switch this out. You know what? I'm going to leave it like it is for now, so we can see the error that I think we'll see occur. So right now I'm kind of just matching, left with my left side spawn, So we'll just let that error ride, and we'll go back in and troubleshoot it and debug it in a little bit. Just kind of pointing out that it probably will happen. So I haven't updated the vectors on my top and bottom wall. So I need to go ahead and do that right now. So again, I'm going to grab, let's grab my player, and let's put him, and let's make sure, yep, that's my top wall. I've got my player kind of sitting inside my top wall here. So now you'll notice something's changed. As I go along the span of my wall, my X position now changes. And as I'm positioning in the middle of my wall here, I can see that now it's the Z value that holds my side position. So we just kind of have to flip-flop it. Okay? So we'll say, let's just start over so we can see we're not getting confused by things. So now we'll say random position will be in my X, Y is never touched, and side position goes in my Z now. All right, and I'm going to copy this guy right here so I can just update this line of code, copy and paste that in. And since we're on the down wall, my side position will now be negative. And it looks like it looks pretty good. Okay. We haven't got to the point now where we can start seeing some progress. But you will now see, so if I shrink There we go. It's updated. All my minimum position and my maximum position is updated. My side position is updated. So fundamentally, looks like our things are updating correctly. We're getting our random values. And you can now see my obstacle direction is updating with up, left, down, right. Things are looking fundamentally sound right now. So we need to go back in and actually start instantiating our objects. So we'll say instantiate, and we're going to say spawned, or what is it? What do we call our spawn objects? Spawned object. There we go. So we're going to instantiate our spawned object at spawn position, and then we have to dictate the rotation. You can see this little pop-up. It asks what we're going to spawn, where we're going to spawn it, and at what rotation. So to handle the rotation, we'll just say quaternion dot identity. That'll basically give us just a default rotation of whatever it normally is. It'll just be a default rotation. So it won't mess with our rotation at all, basically, is what I'm saying. And then I think we just do that for each of these. And I'm wondering right now if we have to put instantiate in each one of these if statements. You know what? I don't think we do. I think we can get away with putting it outside of our if statements. Because as we go through our for loop, we're going to be finding the minimum and max position separately. We're going to find the side position separately for just this one obstacle. And we're going to find our random side and random position uniquely for this unique obstacle. So yeah, I think we'll be able to put our instantiate outside of our else and if. All right, great. And then after we instantiate our spawned object, we need to add a pause. So we'll pause between each individual instantiation of our obstacles. So that's what this code does here. We return, wait for seconds, and we're going to wait our spawn wait time here. And that pretty much does it for our for loop. So after we get out of our for loop, we'll go all the way down here, and that bracket pertains to my for loop. We'll go all the way down here, and that's my wave wait. So you can see the grand scheme of it right here. This is all of my for loop. So after we go through my for loop, how many times we're going to spawn an obstacle during this wave. So we'll do a spawn count per wave. We'll go like maybe 5 times through our for loop. And then we'll kick out of our for loop. And then we'll hit this code right here. That'll tell us to wait how many seconds until the next wave. And then after that's done, we'll kick back up to our while true loop. And we'll start the whole process over again. Hit Control S to save that. All right. So let's see if things are going pretty good. So let's see. I think I assigned that. I'm going to go ahead and make that none. All right. So most of these values should be like, let's reset all of our values here. Okay. And now why don't we test our actual spawn controller? We should start seeing things spawning. So we have an empty spawned object right here. So why don't we go ahead and go to our prefabs folder, and I'm going to drag and drop my obstacle right there. Obstacle direction will be handled for us, so we don't really have to touch that. Let's say that our obstacle speed will be 3. How many obstacles do we want to spawn per wave? So let's spawn 5 obstacles for 1 wave. And how long do we have to wait for each obstacle to be spawned in that certain wave? Let's say half a second. And then how many seconds in between waves are we going to wait? And let's say 2 seconds. All right, so let's see what happens. Nothing's happening. What's going on here? Well, we haven't updated our mover script, but we can see what's going on. Let's go ahead and hide the mesh renderers on our boundaries. so we can maybe see our obstacles spawning. So we can see our obstacles are spawning around us. So I'll select them. You can still see their collision boxes. But we haven't updated our mover script to talk to our spawn controller script. So we're not getting any movement out of these guys yet. But we are getting them spawning around random positions. And if I shrink my boundary in, it is following the boundary right there. Okay, so before we can, I'm going to turn my mesh render back on my boundaries there. Before we can really, and I'm going to reposition my player right into the middle of the screen again. Before we can actually see the fruits of our labor, we have to do one more thing, and we have to update our mover script. Okay, so we got to get our mover script talking to our spawn controller here. All right, so we need to access, in our spawn controller, we need to access the obstacle's direction and the obstacle's speed. And remember, depending on what wall we've selected, with our random side here, we'll pop into one of these right here, and this is where we'll set our obstacle's direction, because they have to go a different direction depending on which wall they're spawning from. So we need to create kind of like a mirror, or a window rather, into our spawn controller so we can look at these values and use them. So what we're going to say is, underneath my destroy and my void awake, and we're in our generic mover, we're not in player mover or game manager, we're in just mover. Let's go ahead and create that window into our spawn controller. So we're going to say spawn controller, this is our type right here. Basically, we're making a variable right now, and we're going to call our variable spawner. Our variable is of type spawn controller, and that'll pertain to the actual class we just made, our spawn controller class. And then we're going to set that equal to, and since my spawn controller is sitting on top of my game manager right here, and since my game manager is public, like so, I can just say, well, gm.instance, and then game object. So this code allows me to point directly at my game object, or my game manager object in my scene. And then from my game manager object, we need to point at my spawn controller script. So then we'll say get component. We're literally getting a component within my game manager, and in every one of these little collapsible boxes is a separate component on a game object. So we're going to say get component, and then what component do we want to get? We'll use a less than sign, spawn controller, and close that off with a greater than sign, and then finish it off with a parentheses. So basically, this line of code has made a variable called spawner that finds our game manager game object and then gets the component on there of the class we made called spawn controller. So now we can say, and this is pretty nice, we can say move direction equals, and our move direction was described right here within our mover script. So we can say move direction equals spawner, and that's this variable name right there, spawner dot what? Obstacle direction. All right. So what is this line of code doing? We're setting our variable move direction. All right. And move dir is very important because these if statements correspond to my move direction. And then we're setting it equal to, well, we're using our spawner variable here, our window into our game manager that controls my spawn controller. We're saying spawner dot obstacle direction. So we're going to my spawn controller, and we're looking at what direction we've set our hazard to. And then we need to do the same for move speed equals spawner dot obstacle speed. Let me get rid of that right there. And I think we're good to go now. And there we go. So a few things to note right now. Why don't we increase the speed of my obstacle? All right, we'll set it to 5. And it looks like my obstacles are dying too soon, so I'll set the lifetime to 10 on my prefab. I'll go to my obstacle prefab and set its lifetime to 10 there. So we can use our game manager now to just create a bunch of different ways we can spawn things. So we can say, okay, I don't want there to be waves, so I'll just do 1 spawn count per wave. I'll make that spawn weight really low, and then the wave weight will control how fast each one of these single obstacles will spawn. So we'll say every half second. So every half second we're getting a new one. And since we only are spawning 1 per wave, every single one of these objects is its own wave, and we're spawning a wave every half second. So it's just a continuous onslaught of obstacles coming at us in different directions. And you can see, shoot these guys down would be a lot harder. Or we can go easy mode, and we can say, okay, spawn 3 obstacles per wave at 1 second apart. So we'll have a wave that'll spawn an obstacle every 1 second, and we're going to wait 3 seconds between each wave. So there's my first obstacle, second obstacle, third obstacle in that wave. And 3 seconds had gone by, and then this is our second wave of 3 obstacles. Then we'll wait again, our next wave, and so on and so forth. All right. So that about does it for our spawn controller. A lot of moving parts here with getting our move directions just right and setting those move directions depending on what random side our random dot range did, and then picking the random position along that wall. So a lot of moving parts, a lot of different I don't know, I guess spider webs connecting all this code together. But taking it one step at a time, you'll be able to connect all the dots there. So don't feel afraid to have to rewatch parts of this video. There's a lot going on here. But as you can see, we got a really cool spawner. And look, I shrink it, and guess what? We're still spawning within our play field. I'll shrink it even more. Without fail, we're spawning obstacles within our playing field. All right, so that does it for this video. Hope you guys have good luck with it.